Hey everyone, and welcome. Today, we're going to decode a kind of secret language. It's literally all around us, from the food you eat to the maps you use on your phone. It's the hidden recipe that structures our entire world, and it's all about ratios and proportions. So, let's dive right in.
Have you ever wondered what makes the perfect recipe? Why does a cake turn out perfectly fluffy one time, but then it's a total flop the next? Or what's the secret that makes your favorite dish taste just right every single time?
Well, the secret isn't just what you put in. It's all about the relationship between the ingredients. And that precise mathematical relationship, that's a ratio. It's the key to getting things perfect every time.
All right, section 1, a delicious ratio, starting in the kitchen. To really get a handle on this, we're going to start somewhere we all know and love, the kitchen. And we'll use a classic, delicious example to see exactly how this whole thing works.
Okay, check this out. A classic idli batter recipe calls for a super simple ratio, 2 parts rice to 1 part urad dal. We write that down as 2:1. It means for every 2 cups of rice, you need exactly 1 cup of urad dal. It's a perfect 2-to-1 relationship. So, quick question, what happens if you double the rice? Yep, you guessed it. You've got to double the dal too, if you want to keep that perfect texture.
So let's try a fun little puzzle. Imagine Vishwanath is making a huge batch of idlis with 6 cups of rice and 3 cups of dal. At the same time, Puneeth is making a smaller batch with 4 cups of rice and 2 cups of dal. Now the big question is, will their idlis taste the same? Are their recipes actually identical, even though the amounts are different? How can we be sure?
Okay, to figure this out, we need to check if their ratios are what we call proportional. Now, that's just a fancy way of asking if they represent the exact same relationship, just, scaled up or down. So we have Vishwanath's mix at 6:3 and Puneeth's mix at 4:2. They definitely look different on paper, but are they? Well, there's a really cool, simple trick to find out for sure.
It's called cross multiplication, and it's super easy. You just multiply across the ratios. So first, we'll take the first number from Vishwanath's ratio, that's the 6, and we multiply it by the second number from Puneeth's ratio, which is 2. And what do we get? 6 times 2 equals 12. Simple enough, right? Okay, now for the other pair. We take Vishwanath's second number, the 3, and multiply it by Puneeth's first number, the 4. And what do you know? 3 times 4 is also 12. The results match perfectly. Since both of those products are the same, it means the ratios are proportional. And that means, yes, their idlis should taste exactly the same. So here's the key takeaway. When the cross products are equal, the ratios are in proportion. Bam!
All right, next section, scaling your world, from spices to paint. This whole idea of keeping ratios the same is called scaling, and trust me, it's not just for recipes. You use it for everything from tiny, intricate spice mixes to, giant buckets of paint.
Okay, a 2-part ratio is one thing, but life gets more complex, right? Let's say you have this special spice mix that uses a 4-part ratio, 8:4 to 2:1. But then, disaster strikes. You go to make it and you realize you only have 2 red chilies instead of the 4 the recipe calls for. So, what do you do now? Do you just give up?
No way! The solution is actually really simple. To keep the taste exactly the same, you have to reduce everything by half. Since you only have half the amount of red chilies, you just have all the other ingredients to match. So now the ratio is perfectly preserved and your dish is saved. Awesome!
And this works for scaling up too. Let's say we're mixing a very specific shade of purple paint. The ratio is 2 parts red, 3 parts blue, and 5 parts white. Now you have 10 liters of white paint to work with. Okay, so in our ratio, white is the 5 parts. If 5 parts equals 10 liters, well, that's pretty easy math, right? It means each part is worth 2 liters. And once you know that, the rest is a piece of cake. Red is 2 parts, so you'll need 2 times 2, which is 4 liters. Blue is 3 parts, so you need 3 times 2, 6 liters. See? Ratios let you build anything to scale perfectly.
Okay, next up, ratios on the map, shrinking the planet. So we've seen how to scale ingredients up and down, but now let's scale up our thinking, like way up, to the entire world. How in the world do you fit the whole planet onto a tiny piece of paper? You already know the answer. It's all about ratios.
I mean, think about it.
Every single map you've ever used is basically a masterpiece of proportional reasoning. The scale written on a map, that's just a ratio. It tells you the exact relationship between the distance on the paper and the actual distance on the ground. It's how everything stays in the right place. The official term for this is the representative fraction, or RF for short. It's the core principle that makes maps possible, making sure that everything, every city, every river, every mountain, is shrunk down by the exact same factor.
So you might see a common map scale that looks something like this, 1 to 60 million. And you might think, whoa, that's a huge number, but what does it actually mean? It's really simple. It just means that one unit on the map, it could be a centimeter, an inch, it doesn't matter, represents 60 million of those exact same units in the real world. So let's say 1 centimeter on the map represents 60 million centimeters on the ground. Now, nobody I know thinks in millions of centimeters, right? So we do a quick conversion, and it turns out that's actually 60 kilometers. And just like that, a gigantic, confusing number becomes something we can actually understand.
Let's move on. A slice of the pie, visualizing data. So ratios aren't just for physical things like ingredients or distances. They are also absolutely crucial for making sense of data and showing it in a way people can actually understand. Ever wondered how pie charts actually get made? Yep, it's all about ratios. It's actually a pretty simple 3-step process. Let's say student grades are split in a ratio of 6 to 5 to 4 to 3 to 2. Step 1, you add up all the parts to get the total. So 6 plus 5 plus 4 and so on. That gives us 20. Step 2, you figure out the fraction for each category. So grade A is 6 parts out of the total 20. And step 3, the final step, you multiply that fraction by 360 because there are 360 degrees in a circle. And that tells you the exact angle for that slice of the pie. And there you have it. By doing that simple calculation for each part of the ratio, we get the precise angle for every single slice. Grade A gets a 108-degree slice, grade B gets a 90-degree slice, and so on down the line. It's a perfect visual way to represent that original data ratio. Okay, on to our final section, proportion in motion, 2 sides of the same coin. Let's look at how these relationships actually behave when things start to change. There are really 2 main types of proportion, and you genuinely see them in action every single day, probably without even realizing it. Okay, first up is direct proportion. This one's super intuitive. It's when one thing increases, the other thing increases right along with it. A perfect example, the more workers you have on a job, the more bricks they can lay in a day. They go up together. Then you've got the opposite, inverse proportion. This is when one quantity goes up, but the other one goes down. Think about driving a car. The higher your speed, the less time it takes to get where you're going. See? They move in opposite directions, but they're still perfectly linked. So it turns out this whole time, ratios have been hiding in plain sight. They're in our kitchens, on our maps, in the data we see. They're even in art and music. They're like the invisible rules that create balance and harmony in the world around us. So now that you know the secret, what other ratios are hiding in your world?